Okay, this is the follow-up video on the video where I created a surface, a gridded surface like this one. In this one we will be creating an alignment, corridors, and then extracting solids from those corridors to create solids. Then we will be linking the dam structure up with this surface, so that we've got a nice interlinking mesh or surface and solids that we can export to finite element software that will be able to mesh without hopefully a lot of issues. We'll be adding break lines and so on to this, but you're more than welcome to have a look. If you have any questions, please ask it in the comments below. Okay, next we will be starting off the structure of the dam itself. I've added a few sections over there, and then also a polyline that will be used as our alignment for the corridor that we will be using to construct this dam. As you can see here, we've got actually only two sections. We've got the spillway section and then the non-overspill crest section. The foundation actually looks similar to the red line, but for now we are going to model this as a plane extension downwards to be able to get an intersection line of our structure on the surface by making use of the actual corridor that we'll be using. And then we will line up all of those faces with that intersection and refine the connection between the foundation and then the structure itself. Okay, so what I'm going to do is I'm going to first delete this so that we don't get confused between those. We will be creating our own assemblies in Civil 3D. That we do by create design, and then we create a subassembly from a polyline. So we've got this one. We are going to call this spillway section, standard, I don't care, that's fine, that's good, cool. So we've got a spillway section over there. Then we are going to create another one. This would be the NOC section. NOC section, and that would be fine as well. Cool, so now we've got two assemblies on that, and obviously as soon as I created those, we are getting issues with my file saving because it's large because of the surface. Let's quickly give that 2 seconds, otherwise I won't be able to do anything, and we're done. Okay, so we've got the two sub-assemblies now. We would like to move its vertex, its origin, to the actual full supply level on that line. So let's just quickly add a snapping point there. Then we select this subassembly, and then we can modify origin, and we choose that origin. Then we go to this specific one, we go to modify origin again, and we choose that point right there. So now whatever profile we'll assign to that alignment will be referenced to the new origins that we've got there. So now what we're going to do is we're going to just copy and paste these so that we've got multiples of them, because we're going to add it to a corridor in a few seconds. Let's just move those to there. Now we've got copies of those, and then we are going to make another copy of this over there. I can delete this one now. So now we've got the spillway and the NOC next to each other. They won't interfere with anything else. Okay, to create solids from these, we will have to modify the subassembly by adding a shape inside of it. So we literally add a shape, so then we select the links If you are familiar with the Subassembly composer, it uses links and nodes and points, and you have to link choose all of the links to create a shape. So there we've got a shape now. Now we're going to do the same thing with the spillway. Okay, so it's first that, then you select the subassembly, then you select the links, and voila, we've got a shape for that as well. Perfect. So that would be our subassemblies that we're going to add to assembly on that alignment, which we will create soon. Now to quickly create the assemblies that we would use these subassemblies on. So we go to assemblies, create assembly. This would be the dam NOC. So we click there, so we've got the dam NOC assembly. We select the subassembly, and then we add it to a specific assembly, and then we click on that thing and it'll move it there. Then we've got that one. We can move this entire thing if we like, but I'm not going to do that now. Delete that line since it's no longer needed. Assembly, create assembly, dam spillway, click, add to assembly, click. Cool, so we've got our two assemblies that we will be using on the corridor to create the actual structure. Now we're going to create the alignment. We're going to alignment, create from objects. We select the polyline we added earlier, check the direction. Now we would like to reverse that line, and we give it a name, dam center line. We do not want to add curves, and then we say OK. Then we've got that. Now we go to profile, we create surface profile. We use the points combined surface, the one that we were using. We do that, we draw profile. We can give it another name as well and change station ranges and so on, but I'm just going to create it as is. Yes, I'm aware that my styles are all messed up at this stage. I still have to sort that out. Then we've got this. Then we go to the profile creation tools. So we select a profile like that. This would be then the line we would like to apply those subassemblies to, the profile line. Let's just call this dam. I'm not going to give it a specific name. That's it. Then this pops up. So then we can create draw tangent lines, curves. With curves, I do not want curves in my case. So I'm just going to roughly draw a line. I honestly don't care where it is now, so I'm going to not limit myself to actual points on it, but I'm going to take it to the fullest extent. Let's make that a horizontal line. Cool, snapping doesn't work in this case. Anyway, so let's do it over there. That's fine for now. Anyway, that's cool. Since we've got that, that's the actual dam. Now we can go to this, and then we can create a corridor. So we go to corridors, create a corridor, and then we're going to call this a name. Let's call this dam corridor, alignment and profile. That's alignment we want. Which one is that? I can't remember which one's the correct one now. I might have messed it up. Let's assume it's the newer one. Let's select this from we would like that one. That's a dam one. Cool, got it. And then we would like to start off with the NOC one. We do not have a target surface in this case because we've got a very simple assembly, and that is it. Then we get presented by this. We can set the frequencies of the cross sections as well. I'm going to change all of this. Why is it in feet? It shouldn't be in feet. Anyway, let's just accept that for now. Rebuild the corridor, and then we can say okay. So now we've got a very slow computer, but we've got a little corridor of that specific alignment. We will continue with this now to create to add the individual subassemblies on that corridor, but obviously moving this to the correct elevation first. The different assemblies to create the different flanks, the spillway portion, and then the other flank as well, and then we'll convert those into solids for FEM. Okay, we're going to create the alignment now. If my model space and project and everything looks a little bit different, I moved everything to another drawing to make sure that all of the units are set to a metric system and not just in this the normal unit settings. So we won't be seeing any more funnies with feet and so on in between of all of the settings that we do. Anyway, so we start off with the alignment, create alignment. We would not do it that way. We would like to create alignment from a specific object. So you select that line. That would be fine. The direction is fine. Then we get this. This would be the dam center line. We do not want to add curves. And we press OK. So now I've got that alignment. Now we go to profile. We create a surface profile. That from that surface. You'll also see that I removed all of the redundant surfaces. That'll just speed up my drawing and then the saving thereof as well. So we draw this in. I'm not going to change any of these ranges at this stage. You can always do that after the fact. So we create the profile view. We click there. Obviously my styles isn't set up properly, so I'm quickly going to set this that it's not exaggerated in the vertical. So we do that. Then we've got this. I'm also quickly going to change the text height so that it's more legible. Then we get it like so, at least the one side. Then we can see that, okay, cool, that line is 130, 1230. Anyway, so now that we've got a profile, we go to profile creation tools, because we need to specify an elevation for that on this profile with the specific line. So we pick that. That would be the dam profile. We do not set anything else. Then this little tool pops up, so we can draw tangents on this. We currently are working with the dam at this elevation, so it's 1, 2, 3, 5. We go all the way along this, and then we go to around about there, and that is our profile for the dam, full supply level at this stage. Cool. So now that we've got that, we can actually create our corridor. So we go there, create a corridor. This would be the dam. Let's call it, yeah, this is just the dam corridor. It's going to be an alignment and profile. Yes, we are using that profile. Let me just quickly make sure that it's that one, so we can select it that way. So that's the one we want. That's the dam one. We want to use the NOC assembly for now. We don't have a target surface because our assembly is very basic at this stage. It doesn't link to or isn't constrained by any surface. So we press OK with that. Over here we can set all of the frequencies and so on. I'm going to set this frequency to something a little bit less. 5 meters should be okay. We do not want it, okay, that's probably okay. We're going to change all of this off. This is obviously going to be more refined later on to have sections exactly where we want it when we create the solid. The reason why we want these sections in specific positions is because that'll form part of the feature lines or the break lines on our structure. So that should correspond to the mesh size that we'll be using later on. Just to give you an idea of how this looks now, we've created a corridor with a structure, and it looks like that. I'll now be creating a similar one, but with the other assembly, the one with the spillway, so that they are both on top of each other. And then I'll be adding sections in specific locations so that we've got precise distances for the spillway for the OG section and then the NOC section as well, and then we'll continue from there. Just a quick note, I initially set my direction for my corridor in the wrong one, so the way you swap it around is you select it, you go to modify under the alignment settings, and then you reverse the direction over there, and then it'll obviously give you an error because it needs to rebuild the corridors. Then you, as you noticed, it's swapped around. Okay, I quickly figured out how to correctly add the corridors, the different types of assemblies on a specific corridor. So we're going to start off with just creating a new corridor. I deleted the old one, so we're doing this, and then on the one bank you will have obviously the NOC, so we're going to do that, creating it as we would normally. But then we're going to, in this view, you can right click on that and then you can add a region after. So when this thing pops up, so then this would not be a spillway, the NOC assembly, it would be the other one, the spillway. So let's call this spillway, and then let's just quickly rename that to that would, no man, I'll rename you left NOC spillway. That, as you can see there, you've got those. Then we're going to insert a region after. That would be right NOC, and then that should be the NOC one. So that way you can specify the changes from station to station, and then the frequency, and then obviously you can go and set a specific frequency for that. I'm going to do it very roughly now. Let's make that 70 meters. So from 70 to, let's say, 140. Not within a valid range. Okay, let's do that 40. That's better. So I'm just going to make it set it very roughly now, just so that we've got something to work with, that you can see how it looks in the end. Let's see if this actually works. I'm not going to, let's change this to let's leave it at 20 meters for now, so we won't have a lot of sections. We can rebuild that, at least we'll be able to see. I don't know why we've still got problematic areas over there, but let's go look at this. Ha! And that looks good. It's a very good start. Actually very good. I definitely like this, and it was very easy to do. Okay, next we're going to see if we can extract solids from this corridor, and that's also relatively easy. You literally just click on it, and then you go to extract solids. Then it asks you corridor regions to export as solids, or so on and so on. We're going to do all regions. Then you can specify the different shapes, and we definitely want the shapes. That's why we added the shapes initially. I have no idea what these settings are, so I'm just going to extract the solids. Normally you get something right off the bat. So now I'm clicking on these so that we can okay, that doesn't, obviously we've got base point issues, but let's try this again. So we've got the 3 different regions, and we isolate those. That's just the solids we've isolated now. Then we can have a look at these. Let's change the view to realistic. So we've got, I'd say, a quick section through the dam. Obviously it is not reflecting the foundation yet, and we will have to be careful with the connection between these, because you can see that's not good. That's not good at all, especially for FEM models. We'll definitely have to do something about that. I'm going to try something. I'm going to union these so that we can see how it looks when we've actually unioned it. first of all, it didn't union. Yeah, so that's not working. Try that again. Error number is that. Looks like I'll have to do a bit of Googling. But that's, even if you didn't want a model specifically for FEM purposes, you could always just at least create one like this and obviously have target set and so on. Anyway, I'm going to see if I can sort out the whole connection problem and that you can actually union them before I create another segment of my series. Okay, so I'm going to try to sort out my stationing for the corridor and the left NOC and then the spill and the right NOC. I've added these yellow lines. That's where the sections actually are supposed to change. As you can see, I eyeballed it completely incorrectly the first time. The reason why my solid also didn't wanna join was most likely because of issues like this. If you look at this, you can see there's two sections relatively close to each other, but they are not perpendicular, they're not exactly aligned properly. So I think the easiest way to do this is to go into your corridor properties. We're going to specify the frequency. We're going to change it individually for the individual sections. I'm going to not make it along a tangent at specific increments. No, I'm just going to change that out to 5 meters. 5 meters, 5 meters. And no, we do not want to put it at specific points at this stage. I'm going to make that 5 meters as well. I'm also going to turn all of these off. This should update all of my different regions. So now that's it. If we go and apply this and we rebuild it, you'll see that the sections are a little bit further apart. It doesn't have to be every 3 meters or 1.5 meters like it used to be before we set these now. So another thing that I'm also going to do is, since we need these solids to link up properly, I'm going to adjust the stationing of this so that the spillway overlaps with the NOCs, and then we can slice the solid afterwards on those specific planes. That'll ensure that the solids actually goes into each other, and we should be able to get a nice joint where we want it to be. Okay, let's adjust the frequency or the stationing of these. Let's see if we can actually allow them to overlap. I don't think it'll allow me to do that. That one is specifically going all the way. How can I look at this properly? Let's cancel that quickly. We quickly go to the plan view of this. We are that way around. So we are looking at like this. We go back to the corridor properties. We are adjusting. Okay, so that's the right one. This is the left one. So I totally screwed up these names, so let's quickly fix this. So you are the just going to add an additional space there so that it can't complain about the labeling, the name thereof. Why can't I select? Anyway, left NOC. Okay, so we would like to adjust this. That one seems okay. So let's see if we can change this to 50 meters. Should be okay. Let's see if I can apply that. Excuse me. Okay, that did not work. Okay, my initial plan to use one corridor with multiple segments doesn't seem to be working. If anybody knows how to properly do this, you can obviously please contact me via the comments below or however you want to. My plan to get past this problem is not to actually have 3 different regions. I'm only going to have 2, but I'm going to let the NOC portion, for instance, run all the way across. So that would be 83. Let's apply this, rebuild that. Let's see if it actually did it now. So we've got the NOC running all the way. Then I'm going to create another corridor, but with the spillway only. So we're going to just get my ducks in a row. Corridor, we're going to add, this would be the spillway now. We're going to use the dam center line, we're going to use the dam one again, same thing, just a spillway one, and then we're going to say okay. This is obviously set to that, but we do not want this, so I'm quickly going to run through these settings. We can probably set this as a standard somewhere. That would be nice if we can do that. Anyway, so we know, no. Yes, 5 meters, no, and no. Perfect. Okay, now that's done. So we apply this, rebuild corridor. We've got this now. Now as you can see it looks like the sections is zooming in on that section, so those sections lines up. Let's do this. Now you can see that we've got the combined sections and they are precisely on top of each other. So that's a good thing. Anyway, now we can let's just quickly look at this from the top and see how the sections link up with the actual sections in the dam. We don't want to that, we want these sections to be roughly in the middle of those, so that we've got a specific, we don't have little tiny faces on the final solid that we'll be creating. So let's do the following. We are going to adjust, we can probably adjust the frequency, or we can, I don't know, I'm not an expert in this, so I'm just going by what I think we can do. I'm going to adjust the spacing, the frequency of the sections, and see how it looks in the end, and then see if we can make those line up a little bit better. I'm going to pause my recording so that you don't have to sit through it. Okay, I changed all of the frequencies of the corridors to 7 meters, and that seems to give us a relatively okay-ish center of the actual joints between the solids. So let's create individual solids now, or extract the solids from the corridors. So we first extract a corridor from that. It would be for all regions. So we extract the solid. We've got the spillway now. Then we do the same thing for the NOC. Once again, all regions. We do that. We extract those solids as well. So then we've got that solid and then the spillway solid. We would also like to select that and the other joint as well. I'm going to isolate these so that we can just see those and then just work with this. So what we're going to do is I'm going to draw a line, just vertical over there and vertical over there, so that we can snap to 3 points when we slice these solids. I'm going to slice both of them at once on 3 points, click, click and click. So we slice those into different solids now. This same with this one side. So we've got those. Then in the middle we would like to delete the NOC, and then on the outer sides we would like to delete the spillway. So now we've got this. This allows us to have these lines link up exactly, and same thing goes for that end as well. So then what we can do is, we know that our spillway length is as long as it is supposed to be, and then we can union these to get a single solid. And as you can see, mostly, for the most part, those lines, the joint lines, actually got removed. It's only in those areas where it didn't, and I honestly don't know why. We can probably, you can see if I hold Control in, I can select individual portions of the solid. You can select faces, you can select lines and so on, and you can even select original entities as well. But anyway, I'm not going to do that now. If you would like to clean the solids up, by the way, if you do not want to be able to do that, for instance, you can type in brep. Brep actually cleans the solid so that it cannot remember what it was made from. So now if I hold Control N, I can only select the individual faces and lines, but no longer the actual left side and the spillway itself. I'm just going to undo it because it is nice to be able to delete individual stuff every now and then. Okay, so that's the combined structure. As you can see, it does look rather well, and we've got clean nodes and clean spacings, which is suitable for finite element analysis. Those lines, I'm not too concerned about them because the meshing will just snap to it. So in those specific faces, we'll have another defining line, which shouldn't be an issue because we'll have multiple faces or elements on that face anyway. So no, that's fine. This is fine. Okay, so next we will be basically creating the intersect line of where this structure intersects our surface. So I'm just going to isolate there. I don't know if you recall, but we had the structure created by the surveyors. They actually gave us a little model like that I can't show you now, that I can compare our solid with at a later stage, but for now I'm just going to hide that again. So that's gone, so we don't get confused on what we're looking at. I'm also going to turn all of this off because it's just going to make it difficult to work with. And then the alignment at the bottom as well. So we are looking at the surface with the structure on top of that, but obviously, as you can see, the dam is still protruding through the bottom of it. So now, to create a solid from the survey, we can actually extract from surface, and we're going to extract solids from this surface, and we're going to do it at a fixed elevation. And let's choose the same elevation that we had for the bottom of that. That would be... No. Come on, snap to something. Snap to something, snap to anything. Click. Okay, let's call it 1175. That's close enough. So from this, extract from this, extract a solid from that at fixed elevation 1175. Creating a solid, and we've got a solid of that. Now I'm going to select the combined solid, and I'm going to select this solid, isolate. Okay, then I'm going to do the following. I'm going to slice or subtract. Let's subtract it. So we're going to subtract this, subtracting that. No, other way around. That subtracting this. And voila, we've got a dam. Then if you do unisolate, let's not do that yet. Okay, basically what I'm going to do now is, if I turn this back to 2D wireframe, and I'm going to explode this as well, so that we are left with the individual faces. I'm going to delete these faces because we are concerned with the boundary line of the solid and how it links up with the actual foundation below it. So what I'm going to do is I'm going to go and delete these individual faces that we no longer need, since they're not forming part of the boundary line at the bottom. Then we can identify the actual points that was used to create the surface initially along this boundary that we would like to remove or add or well, basically modify to get the surface looking the way we want it. As you can see, we've got those as well. Almost sure that we might not want that in our final structure, but that's okay. For now, we don't really, not too concerned about that. And then we've got that face as well. Then over there, we've got those two, and then that one. And then this one as well. And I'm 90% sure that one as well. Okay. So, now if we look at this from the top, what I'm going to do is I'm going to copy this with base point. No, first I'm going to give it a color so that we can see it. Let's make it a weird color, not color 153. Let's make it something horrible, something pink. That purple guy can work. Okay, so then I'm going to copy this with base point. And then I'm going to delete those. I'm going to paste them with base point again. Now we've got one thing that is linked, and we can see what's going on there. Okay, so now I'm going to unisolate again, going back to the surfaces. So I'm going to start with the surfaces we created, specifically the combined point surface, the one that I've added to this. Let's quickly change this. That's fine. I'm going to change the surface style. No longer contours, but let's see the triangles, and we would like to see the points as well. At the points though, I'm going to make this not absolute units. Okay, no, we can keep that absolute units, but let's make this relatively small. Let's make it 0.25, so the actual little dot we see is, well, as you can see there, it's relatively small, so that's good. So now we can see precisely how our surface and our structure would interact. That's the little thing I mentioned that is going to cause problems later on, but I'm going to ignore that for now. So now we are going to modify this surface to clean up the connection with our structure. For instance, that point is definitely in the incorrect place. This should be okay. That might be a little bit off, and we can carry on with this. One thing we can do is physically delete these points, or we can almost create a break line on top of this surface that correlates with the outline of our structure. So we would typically create a 3D polyline and then literally just snap to the, turn off all of this nonsense. Intersection might work. Well, it's actually just nodes at this stage. Anyway, so we would typically snap to things like this to get our break line along the edge of our structure. But this is not going to solve our problem with the short edges that we are trying to take away. So what will work is if we actually go and we delete specific points of the surface. So we would like to go and delete that point, for instance. And as you can see, as soon as I deleted it, it updated this. But this might modify the surface too much. So instead of doing that, we are going to go and create a break line anyway. But instead of snapping to all of the different nodes on this boundary, we are only going to snap to some of them. So that's fine, that's fine, that's fine. Okay, wait, let's go in the other direction since we know that there's a problem up there. So that would be 3D poly. So we're going to start there. We're going to say, okay, those look okay. That is the joint in our structure, so that's fine. Those are still okay. But over here we've got a little bit of a problem. So why don't we, instead of snapping to that one, that one, that one, we only snap to, let's say, that one. So over there we are skipping nodes and only refining it as we'd like to. I should not be snapping to those, by the way, because they are actually part of the corridor, not necessarily the structure. Or it might be fine. Anyway, so that's what we're going to do all along the boundary of this. Yeah, see, shouldn't have snapped to that. Anyway, so we're going to go all along the boundary of this structure with the actual corridors not displaying, and then we'll get a specific break line of this outline of the structure. I'm going to quickly do that, and then I'll come back to you when I'm done. Okay, I've thought about this for a little bit. Using the 3D polylines only is not going to work. The reason for that is the sections used to create the actual structure, as you can see, created nodes on the 3D faces, not linked to specific nodes. So if we skip those, for instance, we will indirectly create problematic areas like this, and for us to add a node there and go on like that, we are adding another node to your surface, and that we also don't like. So I think the better option would be to actually move specific points. So for instance, that point right there, we will move towards that surface, or that link to that node, for instance. So you do modify the actual surface a little bit, but not to that extent of actually removing the point, and you're still relatively close to something that makes sense. So let's quickly move a few points around and see how we can clean this up. I think in the end you will end up using combinations of, so you'll move points and you'll add break lines, and so on. You won't be using just one specific thing. If we go to edit, can we modify a point? Yes, we can move points. So let's move, select a point to move, that point. Move it there. So then it'll update this mesh to look more like that, and it's fine. So technically we're removing that point and that point on the surface, on the intersection with the structure. That one's also going to get moved, so that should technically work relatively well. Let's move that one as well. We are going to move that to that point, and well, you can carry on with this, moving it a little bit. That one is a little bit more tricky. Let's move that one to that line. Yeah, I should obviously be careful to move it too much or too little at this stage, because you can cause problems, and preferably not just in looking at it in a plan view, so that you can physically see exactly what you're doing. But for now I'm going to do this. I don't think it should create too much problems for us, but we might want to have a look at it at a later stage. We're obviously going to not get a finished product with 5 clicks. It might be a little bit more, so we can always go through this and see how it works out. I'm not going to go through the entire process of me moving points around and showing you where I move points and whatnot, but I think you get the gist. Moving, wait, select a point, that one, move that, yeah, broke it. Anyway, edits, move point, that's it. Okay, anyway, so yeah, I'm not going to do that in that much detail, but I think you get the idea of solving tiny problems like this, basically cleaning up your surface that you'd end up with in your FEM model. I'm sure the software would enjoy it, plus anybody that should troubleshoot your solid, your model, will appreciate it as well. Okay, so I've moved a few of my points around. As you can see, I moved that one, and so on and so on and so on. We'll obviously still troubleshoot this at a later stage, because I think I might be causing problems. I don't know yet, So we'll have to figure that out at a later stage. But basically what I'm going to do is I'm going to take this now, I'm going to delete that, I'm going to go back and I'm going to re-extract my solids from my corridors, and then basically recreate the solid we created earlier, and then see how that foundation looks on top of our foundation surface, and that'll give us a better idea of what we can expect, and I'll bring you back up to speed when I get there. Okay, so I've recreated the surface, and then you can see that we've got vertices lining up a little bit better. I wouldn't say this situation, for instance, is ideal, but it is better. Over there you can see that I missed one. But in general we've got those type of situations where you've got relatively clean triangles, equal-sided ones, and on this side as well. There's a weird aspect ratio one, but it's not the end of the world. We would just like to minimize the amount of faces we get. But this situation is good enough, I'd say, or at least an improvement from the original unrefined one we've got. So I'm going to go through this at least one to two more times, then evaluate what I will be doing on the sides of this structure to sort out this, because this is obviously not real. So we'll most likely do a little bit of manual modeling on the edges, but see, that's not good. Anyway, so just to do a little bit of manual modeling to get that more realistic, or at least to such an extent modeled correctly that we are happy with the analysis we will be performing. Yeah, thank you. Okay, I've had a look at the solid and the connection with the foundation that we've got a little bit, and stuff like this is actually horrible for FEM. It's going to cause a lot of stress concentrations, and we definitely need to smooth these out. The way we're going to do that is by adding break lines to the surface, basically linking some of the lines up to better refine it, basically to tell Civil 3D how it should create these without actually manually swapping edges of the surface. We would like to avoid manually manipulating the surface as much as possible, and rather use points and break lines to define the surface so that it can be regenerated without having to go back and then swapping those faces and edges again, just to keep the process as easy as possible, and yeah, basically avoiding all of the manual human input. Okay, so what I'm going to do is I'm going to create a bunch of break lines to see if I can sort this out. It might be a little bit difficult, but for instance, a place where we can add break lines would be, I'd almost say from there on, linking it, let's do the 3D polyline, so from there to that point. And sadly, Civil 3D is a little bit, does that. So as soon as you 3D orbit it, it freaks out and you can't see where you've been. Anyway, if somebody knows how to fix that, please tell me, it'll help. So anyway, we would like to go to that line, if I'm not mistaken, and then that vertex, and then it's a bit difficult, let's go to that one. Okay, if we end that and then regenerate, you'll see that it fixes it, and it actually did almost what I wanted, if you can call that almost. Okay, probably not. Anyway, I'm going to add a bunch of break lines manually to see if we can better define this jagged edge on the upstream and downstream, or anywhere there where we want it, and then also to prevent situations like those where you've got steep edges inside the foundation. So we would like to almost have it triangulated in outwards and then only nicely up towards the daylight, instead of having those jaggedy faces that we've got over there and on that side. That should clean it up relatively well if we get there. Yep. Okay, so now you can see the break lines that I've added. I've drawn them. Now I'm going to add them to my surface, and then we can see how they actually affect and modify our triangulation. So how we do it is by break lines, add break lines, manual break lines. It's fine. I'm not going to change all of these other stuff. This won't play a factor because I don't have any arcs or curves in as break lines. So now, oh man, I should have selected them beforehand. Anyways, select similar break lines, add manual break lines, press OK, and it adds it. Okay, so now as you see, it changed this triangle up, for instance, so that it does that. I don't know if you can see that, but that definitely sorted that problem out. There you can see that one also doesn't have that specific vertex over there anymore. And then over there we also removed all of those jaggedy edges. So it's a little bit difficult to notice exactly what happened now and how it's been modified, but I think this is an improvement. There's a nice one that you can see it. We had basically that thing sticking out like that, and we're replacing it with, well, a triangle that runs at the bottom there, and so on. So we get a better defined face over there. Same thing over there, and so on. Anyway, so you'll have to add break lines all along your structure, and then we'll have to recreate the solid and then see how that lines up with the newly defined break lines, and hopefully we don't get a lot of flat faces or very small faces in locations. Okay, I've gone through a number of iterations to sort out my vertices and edges and so on, by adding break lines, modifying points, moving them, adding them. Mostly, okay, last time I actually mentioned that we should, when we modify a surface, that we should delete the points on defining the surface as edits. I don't suggest any of these delete points, move points, and so on. What we actually should have done is delete the points from the actual point group that we had. That way the modification remains permanent. It's not just a local edit, as we can see here, that because if I recreate this surface now, or I modify my point groups, it'll move these points back into the original position. So that means that all of those edits I made was basically undone, and then I'll have to redo it. That's obviously not what we want. Anyway, so if you make edits, try not to use any of these top ones. I'd suggest only using these bottom ones. If you want to make modifications to it, rather edit the original break lines or contours or points, those type of thing. So when you would like to move a point, for instance, or delete a point, I'd set the surface display style not to show the points, but I'd rather set the point group to show the points. That way we will be able to edit those points and give them a specific style, and then we can delete and move those points. Let's see if these points pops up now, because I noticed that they only show up in, well, absolutely nothing at this stage. Anyway, but I think you get the point that we need to delete those points instead of moving the ones connected to the, well, directly created by the surface. Just to give you an idea of how this came out, let's go to realistic. Actually looked rather well. I'm going to isolate that, and we're just looking at this. Compared to my original one with those horrible jaggedy faces, this is smoothed out quite a lot, where we removed most of the individual stress concentration areas. You can obviously still export this actually to the Finite Element software and then run a quick analysis on it to see if we still get locations where we've got stress concentrations or funny results, and then we can go back and modify the surface and then hopefully reduce the number of errors or stuff we don't like. I see now that, for instance, that little corner right there I might modify again, and then that one as well. So that's the only things that I might change with this. Another thing I will do now is I'll go back to the original survey that we got from the surveyors and fix up the two flanks with the actual structure and how that looks, so that better represents our model, and then perhaps compare basically add in those little walls in there. But this is all going to be manual modeling, so I'm definitely not going to go into that amount of detail now with you guys. And then what I'm also going to do is I'm going to compare this structure to the one that we got from the surveyors, because they created a model, and as you can see it is in between that one and that thing. So I'm going to compare my model to theirs and just see by how much it's off. It almost looks like, it's very difficult to see, so I'm going to take a few sections through it. The wireframe actually shows it a little bit better, and as we can see, the full supply level, for instance, is a little bit lower than we think it's supposed to be, and then you can see the NOCs as well, it's a little bit lower, so we might have to modify our structure and fix that up. I can also see that we don't have, change this back to conceptual view, we've only got the little block there, it doesn't extend all the way across, so I'm definitely going to have to remove that, but luckily that's relatively easy because we just modify the subassembly in that case. And yes, then you can go into the detail of adding those little blocks if needed, but for global stability wise calculations we definitely do not need to add them. Another thing I'm going to add is I'm going to add the downstream notch, if you want to call it a notch, those little sloped faces on the downstream of the dam, which I neglected to put in initially, but this was basically just to prove that the concept of modeling this will actually work, and I have exported this model along with the foundation solid and meshed it, and it did work rather well. I'm also going, like I mentioned, I'm going to fix up these structures. I don't know in how much detail I'm going to add all of these steps and so on, but honestly that's up to the engineer to decide when and how much we're going to do that. For now I'm just going to finish off this video and then see what's going to be my next video. Anyway, so that's basically what I'm heading towards. If you do have questions and comments and so on, and perhaps you can help me out by telling me what's a better way of modeling something like this, especially if we've got a concrete structure with an embankment connected to it, doing the wraparounds and those type of things. Will we do it with gradings? Is it going to be a corridor type of thing? I don't have the knowledge of how to finish those two structures, basically make them interlink properly with corridors. So perhaps you guys can give me an idea of how it should be done, and I would appreciate it. Thank you for watching. Goodbye.